Oh, this is just a little bit of messing around with the memory usage numbers. So this is the line that we always had. This is actually the size of the QEMU process, the resident set size of the QEMU process. And I have dug out some more numbers from the balloon driver that Libvirt uses and QEMU uses. And these numbers now, they should correspond to what is actually happening inside the virtual machine. And there are, of course, complications, but yeah, let's just start this machine. It has something like 4 gigabytes now currently allocated to it, and let's start it. So immediately these numbers go bonkers. So we have to find lots of edge cases, and you have to find some way to figure out if the numbers are correct or not. So at this point, it probably should say waiting for memory usage or something like that. Also, the machine has to be configured correctly to make this all work. So we have to put a button here to enable it. And then there's, of course, machines where this doesn't work at all. And yeah, we have seen some really weird number in between. But once it all stabilizes and the Linux kernel is actually running and all the polling has happened and all the stars are aligned, then we get this number here. And I'll log into this and let's see what free says. Let's make it bigger. So here's free, 3.7 gigabytes about free. And let's see these numbers here. So 3.7 plus 0.9 is about 4.5. Let's say that's the sort of right number. So this is supposed to reflect what the kernel is thinking inside. Kernel says there are 3.7 gigabytes free, and this should now be about 3.7 gigabytes. This is the size of the QEMU process. It's pretty close because it's a big machine with lots of memory, 4 gigabytes. But you know, it's not exactly, there's some overhead. And if you have smaller machines, this overhead is more pronounced. And I don't know what counts as big and small for virtual machines. And maybe 4 gigabyte already is small. So this number is not useless. It's not wrong. This number is better, but it's much harder to get. And yeah, maybe that's the conclusion of the experiment here. There is no real conclusion. And maybe we just take this number and make sure it never goes above 100% to not confuse people. And yeah, if you still have time, maybe we can run through some other machine. I'll shut this down first. I don't know how interesting that's going to be, but you can change the numbers, of course. So this is now stopped. It has 1 gigabyte. Let's give it, this number is quite often wrong here, the maximum allocation. I don't know what's going on, but we can now give it here 2 gigabytes. Where's this coming from? Okay, this. So 2 gigabytes, this number here freaks out a little bit, although the machine is shut off. We can catch that, of course. So, and let's start it. I'll stop the grub thing. And now we don't have any information here because Linux kernel isn't running, the balloon driver isn't running, there's no statistics coming out about the memory usage. But we still have here the size of the process. So kind of interesting still. Let's boot. And it takes quite a while until all the numbers here are in place. Can log in the meantime. So now it goes quite high. 2 gigabytes doesn't seem to be enough for this virtual machine. But yeah, I think it will reduce itself a little bit again. So now the kernel has done some cleanup maybe. Now it's happy. And you can even reduce this to 1 gigabyte, although it doesn't look like it should be possible. but you can do that. And then you can see the number here going down slowly. This number goes down, and it's still not over full now. Now it's pretty full, 900 megabytes, but the machine is still running and has done the reduction. You can also see that in the QM process is also smaller now. And it's still working. So yeah, memory is difficult, I guess. The kernel will take whatever it has and use it, but you can still tell it to use less, and it also will work. Yeah. So there's no clear conclusion, I guess. Just some messing around. Thanks a lot.